Welcome to the Artificial Intelligence course. My name is Mr. McDonald Mkosera. I'm a holder of Masters of Technology in Computer Science. I graduated from Jawaharlal Nehru Technology University in 2014, and what led me there was my Bachelor of Technology Honours degree, which I attained from Iran Institute of Technology, BTech Honours in Computer Science, which I did in Zimbabwe. Actually, the BTech I did in 2010 and the Masters in 2014. So basically, I have at least 10 years experience in the field of information and technology. So what we are going to discuss here is computer science. It's a basic computer science course which is called artificial intelligence. It forms the backbone of computing as far as the advanced computing is concerned. So in this course, at a broader level, it's going to cover the fundamentals and skills that are essential for the design and implementation of intelligent agents that solve real-world artificial intelligence problems, including problems in search, games, machine learning, logic, and constraint satisfaction. So there are certain topics that you cannot skip that are very important in the course of artificial intelligence. These ones include gameplay, adversarial search, logical agents, constraint satisfaction problems, along with techniques in machine learning and other applications, for example, natural language processing. These are one of the basics which you are going to learn as we go through the course. So, introducing this course, the backbone or the basic behind the course, what led to the start of artificial intelligence, in a brief of the history and what led to this course. Just imagine a person or an animal that's a handful of matter. How can it perceive, understand, predict, and manipulate a world far larger and more complicated than itself? So, trying to understand how these things operate led to artificial intelligence. Like they were trying to make computers adapt to this. So, the field of artificial intelligence now, what understanding of this led to artificial intelligence, and rather than just trying to understand how the humans or the animals think, perceive, and operate around their environment, we tend to further create agents now which does the same things as humans does, or little put as animals do. So artificial intelligence becomes a big field which currently encompasses things like quite a number of subfields. Things like general learning and perceptions, learning and perception in general, but to specific things like playing chess, proving mathematical theorems. We've got a lot of mathematical theorems that were proven. You can look on the internet. Writing poetry. These are specific examples that you can use artificial intelligence. Driving a car, the Google, there are a lot of examples. Like for example, the Google car. It involves artificial intelligence to learn to drive a car in a crowded street and diagnosing diseases. Also, it employs artificial intelligence on the medical fraternity, that is the history, the information acquired throughout the process of doctors acquiring patients. We try to model and around that information think about to further predict and diagnose diseases, and also try to notice patterns, maybe to come up with possibility of outbreaks or whatever. So it's not enough. What I'm saying is like just trying to point you to the field, but can you think, trying to understand what is artificial intelligence? What is it? What is AI? Actually, it's defined, and we've got many definitions. Many, that's the key word. We've got many definitions that defines AI, but they are quite two basic categories that all the definitions we can summarize them. The first one is the thought process and reasoning. Basically, when we talk about thought process and reasoning, it's like we are trying to come up with computer systems and agents that think like humans. When we say they think like humans, we are talking about thought process and reasoning. It should think and reason like a human. But humans does correct and wrong things. But in computer, we want to try to come up with a controlled environment, sort of. So we want it to think rationally rather than just thinking about a human. Because humans can think, and they can even commit crime. They can even think negatively. But you cannot program all humans to think rationally, to think proper. So when we talk about thinking rationally, we are talking about thinking the correct way, the correct things. So the thought process deals with thinking humanly and thinking rationally. So thinking like a human and thinking the correct way. So that's one category. So the second category that we can put the other category of definitions are in terms of behavior. So when we talk about behavior, we're trying to talk about how those things, those machines, those systems, those agents behave. So behavior is concerned about how does they act within their environment. So we want agents to act humanly, not just acting humanly, but to act rationally. So to act humanly, we want them to act like humans. That's how they perceive, how they interact. But we want them to do it in a correct manner, like how a human being does in collective. So basically, that's the. I'm not going to define in this course, but what I want us to understand is the basics towards artificial intelligence. So there are approaches that we approach this course. There are 4 of them, but 4 of them are centered or summarized amongst the 2. That is the human-centered approach. When we talk about the human-centered approach, we are trying to put a human being here and try to understand how it thinks and it behaves. That involves observations and hypothesis about human behavior. So we want to observe how a human behaves, and we want to hypothesize the best, whatever, how the human can behave, and we want to put that into a computer system or an agent. We want to put that through software. By the end of this course, we shall have an appreciation of how to do that. The other approach is a rationalist approach, which involves a combination of mathematics and engineering. Here we're trying to put the mathematical models and engineering to try also to come up with an artificial intelligence system. So at the end of this course, one should be able to categorize a particular system that this one is artificial intelligence based on the observations, what we are going to detect, whether through human-centered or the rationalists, right? So centered under that, we have scientists that studied on methods to try to prove that this system is intelligent through certain particular measures. For example, we've got Alan Turing, who came up with a proposal or with a theory that a computer can pass a particular test if a human interrogator is involved. What the human interrogator should do, it should pass some written questions. After passing that written questions, the responses or whatever the process, we cannot tell whether the written responses came from a computer or from a person. So it's like we're trying to pass certain theories or certain tests, and we want the computer to respond, that we cannot distinguish it, was it a computer or a human being. But for the computer to be able to do that, the computer would need to possess certain capabilities, and these are the capabilities that we want to equip our our agents or our systems with. Number one, natural language processing. We want it to be able to successfully understand English. Knowledge representation. We want it to be able to store what the computer or what the systems, what the agents knows and hears. We want it to be able to store that. Whichever method, let's not focus on how it's stored, but we want it to be able to store. Number three, we want it to be able to automate the reasoning now using that stored information to answer certain questions and draw new conclusions from the stored data. Then number four, we want the machine to be able to learn and adapt to new circumstances and to detect and extrapolate new patterns. We want it to learn just as a human being learn. So we want to come up with a system that is going to do all that: natural language process, knowledge represent, automate reason, and machine learn. So Turing test is a test that, like, the responses that we are going to get from a system are going to be the ones that are going to try to help us to come up with a Blair line, whether the responses came from a human or from a computer. So the first point of Alan of the Turing test is concerned with the thinking, the reasoning, the intelligence of a system. It doesn't matter with how it interacts with the environment. But this Turing test was further developed to arrive what they called by then the total Turing test. This is one of the important approach. That's why I'm emphasizing on this. So it did pointed to the total Turing test. These ones, rather than try to think about the reasoning and thinking aspect, it went further to include a video signal for perception, how the humans or how the agent perceives the environment, and to pass physical objects, how they interact. That involves for that to happen, the computer should have a computer vision that will enable it to perceive the objects around it, to perceive what's happening, and it should have robotics. So the robotics will allow it to manipulate the objects around and move about through actuators and sensors, whichever way. So all those disciplines which we talked about in the Turing test, they are the ones that explains or that compose most of the artificial intelligence discipline. So as the course progresses, we are going to understand these, and we are going to learn them, and we are going to have a full and strong grasp that we ourselves were going to design, develop, and implement agents. So one other important approach other than the Turing test will enable us to study and explorate on these rules. There are quite a number of those. We've got 4 of them. Others involve like thinking rationally, whichever. But these are the ones which are most important, which we want to focus on. We want to approach our course in a way that we'll be able to understand this and implement and try to come up with feasible agents. So it should act rationally. Acting rationally, it involves the rational agent approach. So what is an agent? An agent is anything or something that just acts. What is expected from an agent? An agent is expected to operate autonomously, perceive environment, persist over a prolonged time period. When we say operate, it should operate, perceive, it should see surroundings, whatever, here, having that visual aspect, and it should store information over a long period of time and learn. Then it should adapt to change and create and pursue goals. So a rational agent now is one that acts so as to achieve the best outcome over a quite number of outcomes, or when there's uncertainty, it should come out with the best expected outcome. That's a rational agent. So we want to be able to design and develop and model these agents. So this approach, why do we prefer this approach? It's more general than the laws of thought. Laws of thought are one of the other approaches, right? This should be more general approach. Why? Because correct inference is just one of several possible mechanisms for achieving rationality. Also, it is more amenable to scientific development than our approaches based on the human behavior or human thought. I want to give you a simple example why the rational approach wins. For example, if one touches a hot plate or its surface, the correct approach is to react impromptly, come out from the fire without thinking. That's the correct. But if you are following the laws of thought, there are certain laws prescribed that it will have to evaluate and carefully arrive at the decision of removing itself from the fire. So by that carefully, we are wasting time. We will end up damaging equipment more. So this approach is more flexible. So therefore, we will concentrate on the general principles of rational agents and components, on constructing such, because we want agents that are going to operate in a real environment. So I want to make sure each and every one of us is equipped with the knowledge necessary to come up with this. So the only way to do this is to understand how and implement these agents. And as far as artificial intelligence is what is concerned. So at the end of this course, everyone should be able to understand, to model, develop, and design in agents that can operate in a real environment. And also, we should go further to distinguish systems that involves artificial intelligence. So it's one of the most basic building blocks. It's the founding of intelligent computer systems. So we want everyone to understand this and want to learn. And I'm just introducing this, and I want everyone to tune in and subscribe to the more courses and the more subjects as we go through the course, so that we are all equipped and we all model. So this is the introduction, and I look forward for you, for students, to enroll and continue with the course, so that at the end of the day, everyone should be able to design, model, and develop those kind of rational agents, and should be able to understand artificial intelligence systems. So thanking you. Tune in to our next course.